Okay. Okay. I think it's time. It's 10 p.m. Japan time. Let me get started. So this is a 64th episode for Houdini Algorithmic Live, a tutorial live series that I've been doing weekly. And the topic for this week is to create a rather simple modeling stuff, which is this kind of sci-fi style panel using Houdini in a modeling. And as a rendering, I have brought it up into a Unreal Engine 5 using the same method that I have used, that I have recently explained in other videos. If you're interested, you can also watch that as well. But the main goal here today is to create this kind of procedural pattern in Houdini. And the main stuff that I am going to tell you today, the main algorithm, let's say, that I'm going to use today is the one that's called as a Manhattan distance or Manhattan diagram, which is a similar based on the similar idea of Voronoi diagram, but a little bit different based on the how you calculate distance. So if you look at this kind of page, so the one what's called as Voronoi diagram is on the left hand side, and the one that's called as a Manhattan diagram is called on the right hand side. And as you can see that there is a bit of difference between them together. The basic idea of the diagram is how you calculate the distance between the point for the center of the cells and to each of the pixels, and the border is going to be drawn when there is a threshold. When there's a difference between the distance, how the distance will increase changes. Normally the distance will change from these point to all the pixels, going from from each of the pixels it searches for the minimum distance, like for example right here, the minimum distance to any of the points on a display is right here. But when it gets closer to the boundary or somewhere around these boundaries, the closest distance the closest point for this pixel will change from this one to this one at some point. Okay, so based on those closest distance, you can draw which pixel belongs to which points. And using the same idea, you could do the same things by changing the distance function like these, instead of using a Euclidean distance. And by, for example, if you use this formula for the distance calculations, you'll be able to get this kind of straight line using a straight line on horizontal, vertical direction, and as well as a 45 degrees angle. Okay, so this is what I'm going to use today, using this formula to calculate the Manhattan distance and use it to draw this kind of pattern onto then use it as a base for the sci-fi panel. And that is mostly the main stuff that I'm going to do today. And it's not that hard to do in order to create this drawing. If we are talking about the pixels, meaning like 2D image, but when it comes to draw these kind of polygon lines, the line for the polygon becomes a little bit hard to implement, especially when it comes to these corners. And this is not so precise in terms of the real Manhattan diagram, but it's a bit of fake here. But I'll show you how you can achieve this kind of stuff. Maybe if you know some more about geometrical functions in Houdini, you'll be able to implement a bit more wisely. Right. So let's get going. I am going to start by creating a geometry node. So basically the main goal here is to create this Manhattan diagram instead of the Voronoi diagram. Okay, so I am going to start by creating a basic plane using grid. And first thing you want to decide is how much of a resolutions you want to achieve. So by increasing these rows and columns, you'll be able to define the resolutions of the final image. Okay, since I am going to use these lines as a baseline for the diagram, for the Manhattan drawing diagram, so everything is based on these line, the horizontal and vertical lines. Okay, so keep that in mind, and I will going to create a new node. Name it as controller. Okay, so first parameter that I would like to add is a resolution for the plane. I am going to create an integer parameter. Let's name this res, from range from 1 to 50. Okay, I'm gonna start with 30. Copy this, paste it right here on the rows and columns. Alright, now same as Voronoi, I'm going to define the center point for the cells. Okay, so could be anywhere. So I am going to just create some scatter point using scatter node. Right, it might be too much of a point with these ones, so I'm going to define how many points I want as well as a parameter. MPT. Okay, so from 0 to 10 or 20 or maybe 50. Okay, let's say the default value is 20. I'm going to plot 20 points on top of a plane. Alright, so this point is going to be the center core of the cell for the Manhattan distance. And I am going to uncheck this relax iterations to have a bit more interesting pattern rather than having all the points have the same distance between each other. All right, so let's also create another grid for the or let me just try to see what it looks like if you just use the normal Voronoi fractures with these plane and the point, and see how it looks like. Now I'm going to uncheck the create interior surface. Right, so the divisions looks like these. You have this kind of pattern. Now what I would like to do is to, instead of creating this kind of Voronoi pattern using the Euclidean distance, I'm going to try to create this kind of pattern on the right hand side. And this page actually explains how you can implement it using Houdini by converting the Voronoi pattern into a Manhatter pattern like these. But I have looked at it, and there is a bit of problem with this implementation, especially if you look at the angle right here. It's not really a 45 degrees, but it's skewed. So the implementation here looks like what we are looking for in terms of Manhatter pattern, but it actually is not. So I'm not going to follow this one, but instead I'm going to do my own way to implement what I want. Okay, so like I said, in order to implement the Manhattan distance, most of the time it's easier to work with a pixels rather than geometrical like operations like using an intersection and so on. So let's try to do the same way using like pixel based operations. In this case, I am going to refer to each of the point position, and I'm going to think that each of the point position is a pixel positions, and use that to estimate this border positions. Since the border is either straight on horizontal direction or vertical direction, or a 45 degrees diagonal direction, even though I have small number of pixels, in this case a point, should still work cleanly because the angle are really limited, so the division could be really clean itself as well. Okay, so let's try it out. I have now the plane and the points. What I'm going to do is to calculate the distance using the point wrangle. So for each of the point on the grid, which means in this case a pixel, so from each of the pixels, I am going to look for the closest distance point from the second input, which is these core points. And I cannot really use the function like near point or any other like closest distance related function, because all of these functions are based on the Euclidean distance. So I have to implement my own distance searching functions to be able to get what I want, in this case a Manhattan distance. Okay, so let's look back to the function, the distance function right here. Okay, so it looks like these. So for each of the pixels, in this case I am using a point wrangle for this grid, so I'm accessing to each of the point as a pixel, and I'm going to loop through from each of the point. I'm going to loop through all those points from the second input and check its distance, in this case a Manhattan distance. So I'm going to use the for loop int I equal to 0 until endpoints 1. Okay, and then let's also get the point position from the second input, which is the center of the cell, using a point function. Okay, now normally if you want to calculate the distance between two, you can use function like distance, or you can even just search for the closest distance by using a near point and so on. But right now you cannot really do that, but you have to implement your own distance calculations by using the function that was written in the website, which was like this. So the position is called pos, and pos.x minus the current point position on the pixel plus absolute position dot z minus at p dot z. Now, not considering the y because there is no y direction available here. It's on the 2D plane. If you are working on the 3D set, then you can just add one more coordinate. Okay, so this is going to be the Manhattan distance, and and what I want to do is to pick the closest distance out of all the points from the second input. So let's find that out. I'm going to create the min distance variable starting from a rather big numbers. Then also create a index to show which point has been chosen. And I'm going to create a comparison here. If the current min distance is larger than the distance that I have searched right now or calculated right now, then replace the minimum distance variable with this distance and also update the index with I, which shows the number of points from the second input. Okay, now as I have calculated everything through these loop, I'll be able to check which point belongs to which point. So let's try to visualize that. I am going to first create the integer attribute called val and apply this index as a value, attribute value, and let's also apply the distance as well. I'm not sure if I'm going to use it, but just to see how it looks like. So distance is min dist. Alright. Okay, so after I have done it, what I would like to do is to visualize, first of all, visualize this value, which indicates the index number from this second input point. So, meaning if this pixel belongs to point number 0, then it will, which means that the point is closest to the point 0. So to visualize that, I am going to use the color node. Okay, let me just save this somewhere. And make this ramp from attribute or random from attribute and use attribute val. Okay, so this shows which point belongs to which cells with the colors. Okay, so this is one cell, this is another cell, and so on. And if you try to make the resolutions a bit more higher, you'll be able to see a bit more clearly. If I increase the resolutions to 200 or something, you start to see its borders like these. Right? So this is the actual like panel outline that I would like to get when I out of these informations. Okay, currently what I have as an information is the integer value applied at each pixels or at each point, and currently I don't have any like informations where the boundary is. Okay, but what I would like as a final output is to create these boundary outline to this boundary. And let's also look at the distance value, how it looks like in terms of the data. So let me go back to the geometry spreadsheet for this point and look at the distance, and I'm gonna check the minimum and the maximum distance value. So the minimum is 0, the maximum is 4.6 or something. So let's try to visualize this. I'm going to place this as a distance and change this to ramp from attribute, so 0 from 4.6. Now it looks like this kind of pattern. It's a bit hard to see here. So the distance when you calculate the distance, it will look like a cross like pattern, which in result you get this kind of straight diagonal or straight border line like these. Okay, if it's Voronoi, then it will become more organic shape. Okay, but so what I have to decide here is how I be able to get the boundary informations out of these two informations, either index or the distance. Now, what I could do as one of the idea is to use this index. Let me go back to the random from attribute and change this to val. Now what I could do is to check each pixels, and if at some of the pixels, if you look at the neighbors, you see a different value. For example, if you are looking at this point in a point wrangle and this value is equal to 0, then if you look at the neighbor points from this point, like for example, this point has a different value, the different index right here on the right hand side. So that's where you want to create the boundary. Okay. So by doing those comparisons, you'll be able to define which point or which pixel should be used as a boundary. So that's what I am going to do. I'm going to decide which point to be used as a boundary and pick that boundary to create a certain split line. Now let me go back to make this resolutions a bit lower. Now another question is, then what as soon as I found these boundaries, there is several type of conditions, like how I need to split it. Like for example, for this one I need to split it in horizontally, up and down like these. For example, in this case, this has to be splitted like diagonally. So you probably want to create the line somewhere around here. And for this grid, you want to create a diagonal line like here. Okay. At some point, you have three corners, three values touching to each other. So for this point, it's touching both to the green one and the pink one and the red one. In this case, you might want to split in some other ways. And these one as well, these places as well. And at some point, you are having like 4 corners as well, like these one. So considering all those conditions, you need to replace those. You replace this block with corresponding a pattern, and I am going to use the similar principle that is used in a one called marching square. Marching square is used in converting the pixel pattern into a polygonal pattern, a polygonal geometry, by checking the boundary informations, and based on those boundary, changing its pattern to these kind of shapes. By doing it, you'll be able to convert pixels into this kind of polygonal by combining these modules and use these to create a polygonal pattern. The same principle can be used for 3D as well, and that is called as marching cube. Now I'm not really going to use the same marching square, but just using the similar principle. It's going to be a much easier one, but maybe you could remember what this for. Could be useful for many other purposes. Okay, so keep that in mind, and let's try to do that. Okay, let me rename this to Manhattan distance. Okay, so what I'm going to do, I am going to use the, since I would like to solve for each primitive, in this case, faces, and choose whether this face should be splitted or not. So by looking at each faces, I can check all the 4 corners point, and if one of the corner has different value compared to the others, then that's the one that you want to change it as a splitted corner at the boundary shape. So I'm going to use the primitive wrangle to achieve that. First of all, I need to check whether the current primitive that I'm looking at, these faces, should be at the border or not. So let's first create these conditions. And I'm going to name this solve edge. Alright. Connect the colors to right here. Okay, so first thing first, I am going to retrieve all the points from the primitive, and probably it's a good idea to get in a clockwise or counterclockwise direction order so that I can check one by one from point to point in a counterclockwise order. I mean, in an order will be easier to create a split with that way. So instead of using the prim points, I'm going to use the function called prim vertices, which preserve the point order, which you can get the list of vertices from the primitive. Okay, let's check this out, how it looks like for each primitive, if it's 5 or 4. So currently I have 4 vertex numbers right here, and this is not the point number, but this is a linear vertex number, which is which belongs to the number on the left hand side, but it doesn't really show up the linear vertex number. These are the combination between the primitive number and the index number for each primitive. So the actual vertex number you cannot really access from the geometry spreadsheet, I guess, but only available in Sci-Fi. Please correct me if I'm wrong. So what I would like to do now is to convert this vertex number, each of the vertex number, into a point number so that I can get the necessary information like the value attribute and the positions. So I am going to loop through all the vertices. Get the vertex number and change this to a point number using vertex point. Vertex point, yep, like these. Okay. Now, okay, now I would like to check if there is a difference between the, if there's a different value included inside the 4 points or 4 vertices as an attribute, in this case a value attribute. So I'm going to check, I'm going to just get the first attribute, the first point attribute from each of the primitive, just by getting the first index from this vertex. So int bt0 is equal to bts 0, and also get the pt0 using the vertex point function. And from this one I'm going to also get a value 0. point 0 value at pt 0. Okay, I think I've written pt9. Alright. Okay, so first thing first. That I have those. Okay. And what I would like to do is to get a list. What I would like to do first of all is to create a list of list of values for each primitive to indicate how many different values, how many different indexes it has for each primitive. Like for example, for this primitive, it only has one type of index, one type of values, which belongs to this pink one, the dark pink color. So probably the number of list is equal to 1. When it comes to this one here, which touches to this light pink color and the dark pink color, you have two types of values. So the number of list for this primitive should be equal to 2. This one should be equal to 3, and so on. So I want to create that kind of array or list, contain all the containing indexes. So to do that, what I am going to do is to create the, first of all, starting from the empty array containing all the values. There's an integer list, integer array. Then inside the for loop, I'm going to append the value that I have found out from this point inside this array. Okay. And this spell mistake. All right. And another thing that I would like to do here at this point is to, using this same array right here, I probably would like to see when does the change for the border begins. Like for example, if I look at single primitive like this one, and if you look at the number of this primitive like this, let's make this size a little bit bigger. So this one goes 0, 1, 2, 3. Actually, I am getting the order based on the vertices. So what I'm doing inside a primitive wrangle is to reorder the point using by vertex order. So the actual order looks like these. Doesn't really change, does it? By vertex order. I guess I should do it like this. Okay, so the actual order inside a primitive wrangle looks like this, going clockwise from 0, 1, 2, 3. And what I would like to know is when does this value changes start? Currently, from counting from 0 to 1, the value from 0 to 1 doesn't really have any value difference. The value for the 0 and 1 is the same. If you look at the value for 1 and 2, the value changes, meaning in this case the color changes. So this is the point where you want to create this split line right here. Okay, so you want to the value that I would like to record here is when does this split starts. In this case, starting from 1. Okay, then for the other stuff, I can just do it. I can just do the process with the other functions. But the one that I want to know initially is to check when does this split starts. So in this case, it starts from between 1 and 2. So let's try to have that information as well inside the same loop right here. So to do that, I do need to have a next point number as well, rather than the current point number inside the for loop. So let's get that as well. I'm going to rename is vt2, getting the I+1 index. And if it goes over the number of BTS, I have to reset it to 0. So I'm going to calculate the remains. Then change this to a point number, just like I did for the previous one. And then get the value 2. Then what I would like to do now is to compare these two values, the one previous one and the one that's next value. And if these values are different, then that's where you want to start doing that's where the split start to happen. Okay, so as soon as it finds out the split, you don't have to calculate the splitting anymore, so you can skip the later process and only use this one. So I'm going to create the value that I would like to store as an offset starting from -1, and I'm going to create the conditions if offset is equal to -1, and if the value is not equal to value 2, then that's when you want to update this offset, in this case to a value, or maybe instead of value I'm going to say a I, which indicates the index of this vertices. Okay, that might be useful. Okay, so by doing that, I have just created two informations. One is this offset, which indicates from where the split starts, and the array of values. In this case, I have 4 values for each primitive because all the primitives are squares containing all the values for each primitive. Now, but as I said, the value that I really want is the only the unique values stored inside the array. So if all the values are the same inside arrays, then I want to trim it out so that there's only one values stored inside the array. So to remove all the duplicated values from the array, I'm going to first of all sort it out from small to big using a sort function. Then do another for loop looking from the index 0. In this case, I have just sorted out, so looking from small value to the larger value. So by doing that, you'll be able to check the one next to the current value, and if the one next to the current value is the same, then you can just skip it and go to the next one until you get the different values. So let's get the, so in this case as well, I need to have 2 values to check the next values to each other. So values vals I int val2 vals I+1 lengths of vals. Alright. Okay, now that I have these 2 values, I'm going to check if a value 1 is not equal to value 2, then that's the one you want. So I'm going to create another new array here. Let's call this nvals. And as soon as you find out, maybe starting with the value 0. So the initial, I'm going to create a array which contains only the first value from these values, from the value that I have sorted out. I should do it after I have sorted out. Okay, and I'm going to check all the values inside the sorted out values array, and if the value with the previous one and the next one is different, then you want to add that value to the this new array that I've just created, which is this one right here. So let's do that. Wait a minute. Okay, I shouldn't do like this one because I shouldn't loop. I mean, I shouldn't wrap the array. Like if the values index goes over the length of the array, then it shouldn't go to 0 in this case. For the comparison, it should always look for the one what's next to each other, the value next to each other. So instead of using the modulus calculations, I am going to make the total number of array comparison like these, so that I can still use this I+1 as an index to get the value 2. And if this condition met, then I am going to append this value 2 to the array, to the new array. Okay, now it's time to check whether I got the necessary information for each primitive. So let's check this out. I'm going to check the primitive wrangle, and okay, so the primitive number 0, you have only one number. Let's check this out. The primitive number 0 is this one, so it only has a single index or single colors. So the number 1, the number of the array is equal to 1 seems to be correct. So if I look at the number 5, which in this case it says you have 2 values, and if you look at the value number 5, which is this one, it is at the border, which has a color on the left and another color on the right hand side, so having 2 values seems to be correct as well. Now let's check if there are any which has 3 points or 3 values, like this one, 564, 564, which is this one. So if I look at this primitive, it has this yellow, light yellow, and this purple for this primitive. So having 3 values seems to be correct as well. Okay, so I think this is okay. Now let's keep going with this information. Alright. Now you might be wondering if there are any more easier way to like split these as a border. Now there is actually several ways you can do it easily without using these wrangles, but not so if you use that process, it's not that precise. I mean, you do have a little bit of margins when you trim out. One of the way you could do without using the wrangle, since for each points right now I have this attribute called val. Where was it? Val right here. So based on this value, I could create a loop and use that. And for each of the loop, I can just change those I can just pack this geometry into one, like polygon, and retrieve the outline curve. And that might be easy way to do, but there's a bit of problem with that one as well. So if I want to do that, I can use something like for each named primitive and change the name value to val. Based on this val, I can access, okay, I think I have to change this to points. Alright, well, I guess I have to promote the point attribute to the primitive as well. So attribute promote. I'm going to promote from point to primitive the value. And I shouldn't use the average, but I'm just gonna use the first match. I don't want to delete the original. And change this to primitive. Now by doing this, you'll be able to access to each of the primitive like these. But as you can see, the corner is not diagonal like these. So you don't really get the clean divisions like I want it. So it's not really a good idea. Or another way I could think of is to, for example, use the for each number. And in this case, the number of cells is the number of points right here. So I can just copy this expressions, paste it right here. And for each of the loop, for each iterations, I can try to delete the value, or change this to delete non-selected, and delete the one that's value is not, or value is equal to the iteration value from the for each count. Iteration, and probably I should make it as a expression, and you get the same thing. Okay, I think I should do the point. Now if I use the point, then you get a bit more nicer triangulated result, but the actual result you get is this kind of offsetted polygon, which some of you might be okay, but in my case I wasn't okay with these output, because what I wanted is this middle point, the middle direct, the actual border to split the geometry, but this one doesn't really have the original border. The border has been gone with this one, so this is not really what I wanted. Okay, so that's kind of a reason why I'm going to use this wrangle to achieve the split instead of using this easy way. There might be a smarter way, a more easy way to split these based on this value informations, but for now I couldn't really think about it. So if you have any idea how you can split these based on those values, please throw out your ideas. If not, for now, I am going to use this a wrangle approach myself. Right. Okay. Now, where was I? I have just created the integer array called nvals containing all the individual or all the unique index values containing for each primitive. Now if it's equal to 1, then that's not the border we are looking for the split. So if the length of nvals is equal to 1, then we don't really have to do any calculations. So I'm going to keep this keep this conditions empty for now. Probably I don't need to do anything. I think, yeah. I'm just gonna apply the primitive attribute set prim attrib as val to this primitive with the first value from the nval. Random thought, but maybe a half edge. It was shipped with Houdini 18.5. Half edge. Is there a half edge node? I have been using half edge in Wrangle, but haven't really seen any node related to half edge. Not sure. What about a Sdf workflow? Yeah, Sdf might be easier in this case. You might not be able to get the clean, like straight lines, but at least you'll be able to like have the high res to be able to mimic the result, and it can also be used as in 3D as well. So probably using SDF makes sense. Group from attribute boundary. Group from attribute boundary. Yeah, I can do that. Attribute boundary. Let me check that. I haven't thought about it. Group include by boundary regions. Group from attribute boundary. I'm not sure if this one will be able to can be used or not. Bounding object points per loop. I'm not really used to these group node. I'm not sure which ones to use actually. Let me know if you have any like idea how I could use these or this one. I might have to look back. Alright, let me just leave this for now. Group from okay, group from attribute bound. Never used this. Group from attribute, group type, edges. Wow, looks like this seems like a nice one to try out. Let's check. Okay, so edges, group type, base group, attribute, point, val. Okay, so seems like I got this. It's close, but not what I really wanted, I guess. If I use the point, maybe. If if I use this one, I guess I need to create a kind of split line somewhere so that I can choose that edge somehow. Looks a bit hard. Still need to do some split to the polygons using this one. Promote ID to primitive. Okay. So the value has been promoted right here. So if I use the primitive instead, blurred IDs. Yeah, I think it's this one is not blurred because it's just using the first match. It's not using any average or anything. So but I still don't see if I can use this. Wow. Yeah. Probably I might this might get into the same problem with these one or these one. Okay, well, let me think it back later. See if I can use this one, but for now, let's go back to the wrangle. Maybe the SDF approach might work. Maybe I can try that as well. Try that part. In that case, I could use a three-dimensional pattern, probably. Maybe divide the prims. Divide the prims. You mean split the prims? Triangulate. Well, the problem with this divide is that you cannot really define like in which direction the triangle is being created. Like, for example, this one, I want the line to be created in this direction, but probably this one doesn't really control. So you get this direction. So might not really work. It's really hard to control. Actually, I have tried creating like a cross like pattern to see if I can use it, but didn't really work as well. Instead of using divide. So it's pretty much a hard questions how I can solve it easily, I think, but maybe there might be a easier solutions to this one. I wasn't able to find it myself yesterday. All right, so let's create a conditions else. So if the unique value is more than 1, meaning you have the primitives at the border, then let's try to think how I can create the split lines. Okay, Robin Bonehurst Labs has a extract borders. You can create unique UVs by IDs and then use the extract borders. Interesting. Let me check that out. Extract borders. Okay, let me see. UV borders. Let me check how you can use this one. This node converts the model to curves, either by extracting the mesh boundaries as curve or by splitting every point as output. Simply a wrapper around the divide node, which isn't very discoverable, as well as first text split. Unroll the mesh and delete all the primitives. UV toggle between output and outputting the geometry boundaries to curve, either by extracting the mesh boundaries as curve or splitting every point. A wireframe version of frame. It seems like you still need to have a mesh line with this one, doesn't it? Thinking like that. Currently, I don't really have any split line or the mesh lines to each of the primitive, but if you want to use this one, it seems like you do need to have a mesh lines or mesh wires to extract that as a curve. Thinking. You can create unique VS IDs and use them. I guess that if you run over primitive ID in for loop and just generate a planar UVs. I'm not sure what you mean by planar UVs. Wait a minute, labs. Extract order. So it's toggles between outputting geometry boundaries versus the UV boundaries. Let me try out with the small example. I'm just going to create a simple grid 2x2 and try to modify its UV and see how this one outputs. So I'm going to use the point wrangle. I'm not sure if the has to be UV or I mean the vertex or points. Let me try with points. And going to try to set the UV. First of all, based on the point positions divided by 10 and then add it by 0.5 0. Okay, let me check it out. So I have UV. Okay, probably I need to replace y and z. So uv dot y is equal to v at uv z, v at uv dot z is equal to 0. Now let me then try to change the y value for the uv, maybe multiply by 0.5 and see how the border changes. Doesn't really change. I'm not sure if that's because I'm using the point attribute, or if I might need to bring this to a vertex attribute promote. Let me bring up the point to a vertex, the UV. Now the UV has its own UVs, and the vertex has its own UVs. Okay. The boundary doesn't seem to change, does it? Even if I modify the UV value. I'm not sure if that's the case or if you are mentioning something different. Not really sure. Haven't really used this one and don't know how exactly this works. Toggle between outputting the geometry boundary versus the UV boundaries. Not sure, not really sure. You need different UVs island, I think. Okay. Try. Different UVs island, polygons. Can't really imagine how this works actually, honestly speaking. doesn't. This node converts model to curves, either extracting the mesh boundaries curve or splitting every point 7.5 frame version mesh. Wrapper around the divide node, which isn't very discoverable, as well as vertex split and face facet to provide additional functionality. To curve either by extracting the mesh boundary curves or splitting every point and or putting a wireframe version of the mesh. Yeah, I can't really imagine how this really works, or does it? I don't know what to input in order to make this work. Yeah, let me just skip this one. If you have direction, like if you have any like example page, or if this one has an example file, let me check. This doesn't. To me, it looks like it's just converting the mesh into a directly to a curve. If I disable all these, not sure how this works. Sorry. Well, let's keep that. I'll just look into it later myself. Two parallel divide node with different directions and merged. If you calculated the convex hull of point with the same value, would that work? Okay, so thanks for all the ideas. So two parallel divide node. Actually, I tried that and didn't really work. If you calculated the convex hull for points with the same value, I think you get the pretty much the same stuff you get with this one. I think probably. Let me not, because each point has its own unique value, which means you still are getting these like margins between the points. Let's see. I'm not sure if there's some parameters for the convex hull. So in order to use this one, you still need to somehow split all these into a different cells, and probably you need to okay. Actually, this convex hull might work if well, not. Actually, not, because convex hull wraps wraps the geometry without any like concave, and like this kind of geometry is a concave geometry, like this shape. So if this convex hull cannot be used directly with this kind of shape. So probably not. Probably not. Okay, I got one idea. That is, the problem with this approach here is because I am using the point values to delete the geometry, but instead, if I can get each of the cells, wait a minute, it's a bit hard to do. Well, the thing is that there's a kind of a need to get the center point of the border right here, and that is equivalent to the center of the primitive. Right, so if I can get, instead of using the point, if I use the primitive which is at the border, then I could probably do it. But another problem here, if I just use the center point of the primitive as a split positions, for example, this one right here, if you get the center points, then the points comes right here. Now this primitive is also connected to this one, which is the different value with this one and this one. So the center points comes here. So as a result, you still get this kind of radar-like pattern, which might not be a ideal pattern. Right. It's pretty hard. Pretty hard, isn't it? So, getting back to the original, I'm just going to try to convert all these edges into the corresponding split pattern based on the marching square idea. Okay, but thanks for all the ideas. Some of the ideas sounds really promising. I just don't know much about these new node that I have not been using myself. So I gotta look into it myself before using it. It's probably my fault, but please bear that in mind. Okay, so where was I? So for the borders, I am going to create a split geometry. So let's think about this kind of geometry. So first of all, I have this offset value determining from which index does the split starts. In this case, somewhere around here or somewhere around here. So using those values, I am going to create a for loop, looping through all the vertices again. In this case, starting from a offset value so that you can directly start from the split index. Okay, and then I is until the length of ETS plus an offset and increment it by 1. Right. Now, let's, so in this case, I am assuming for this primitive, I'm assuming the point starts from this point right here, or maybe right here. Let's just assume that the point starts from here. Now, in order to get the middle point between the values 1, which is this pink value, and the value 2, which is this red one, I need to have the next point value as well, the point information as well. So what I want to do is to get 2 vertex numbers, one from I and one from I plus 1. Right, and then just as I did previously, I'm going to convert it into a point number, vertex point from VT1, vertex point VT2, and let's also get the values. Value 1, value attribute from the point 1, and value index from 2. Right. Now, I know that the first point is the first index. If I have used the offset, the first loop, the first iterations for this loop starts from the position right here where you have the values different. But there is a chance that after this first iterations, the second iterations you have the same values. So I am going to check if the value 1 and value 2 is not equal. And that's where you want to add the middle point right here for the split. So let's do this. So I'm going to create the middle point by naming the point number and then use the add point 0. Now I probably need to get the point positions for all those points, so let's also get that as well. Vector position 1, pt1, vector position 2. Alright, so the middle point should be position 1 plus position 2 multiplied by 0.5. Right. Okay, so let me check if the point has been added. Apply, accept, and I'm going to enable this one to see if the point has been added. Okay, so I can see that the new point has been added where I want the split to happen, like these. So if you look from far away, you can kind of see these outline being a bit dense. Now, why am I having the points right here? What's this? Huh, I think it's the cached points coming from somewhere else, isn't it? There's no reason to have these points on the middle of the primitive, does it? It's weird. If I turn this off, okay, where does this come from? Sometimes I have these cached geometry and not be able to do. Okay, I think it comes from this one. Okay, it's not going away, so I'm going to reopen it. Okay, still there. Ah, okay, still there. How come? Just gonna delete all these unnecessary stuff. Alright. Let me reopen this back again. Still seeing. This is kind of a most annoying stuff with Houdini, having these cached geometries shown up for an unknown reason. And I don't know how I can get rid of these. Okay, is this because of this one? Huh. Seems like it has been added with this solve edge function that I've created. Let me check. So the primitive number for this one is 740. So what I'm gonna check is going into the primitive 740 right here. Okay, what's this value? Okay, let me also apply this n values as an attribute. See what's wrong. So n vals 704. So I have just one values right here. So I should not be able to get any kind of points right here, which I see it's okay. I do get the point number right here for some reason. Interesting. And why is this? Like these one, why am I having these points? I might be doing something wrong here. Huh. If I disable this one, what happened? Okay, it's gone. Probably I am doing something wrong somewhere on here. So I'm doing the for loop. I goes to offset. I is less than the length of vertices. Okay, so thank you, CG Dingo. You're getting the same results, so I think I am doing something wrong with the calculations. Alright, let's see where. Offset. Removing the offset from the loop helps. Okay, so I guess this is doing something wrong here. But why is that? This is just to wait a minute. Okay, this is just shifting the array, so this shouldn't really be the problem, but okay, let me check. For loop until offset. Okay. Huh. I probably let me try to delete this for now. Change this to 0. Change this to 0. Okay, so this one seems to be okay. Now, if I add the middle point, okay. Okay, now why does the offset doesn't really work? If I start from 1 and then until +1, okay, now I start to see some problem right here. Okay, now I know. The reason here is because I did this modulus calculations assuming that this goes over the length of the vertices, but if I do the offset, then this I value might also go over the length of the vertices, so I gotta do the same modulus calculations right here, calculate the remains right here. Alright, now this should work. Okay, go back to the offset. Okay, totally forgot about it. Alright. Now this should be okay. Everything seems to work fine now. Now that I have got the middle point, let's go to the next step. So, where was I? So, let's assume that I am looking at this point right now. And the next thing I would like to do, is to create the primitive starting from this point and create a square shape like this. Okay, for this side. Okay, so if I'm starting from this index and I'm looping through all the points clockwise, the first point that I've created is this point. The next point I would like to create is this point right here. Then go to the next loop iteration, and in this case I'm not going to add any midpoint, so just straight ahead to this point. Then if there is a value difference between 2 points, then I'm going to add a middle point again. Then as soon as I have the second middle point, I am going to add this, close this as a polygon. Then start creating a new polygon from this point, doing the same process until it meets with other middle point. Okay, so that is the process that I would like to create here. So as you might be able to imagine, a lot of conditions might need to be created in order to achieve that. Alright, so after I have created the middle point, the next thing I'd like to do is to create probably the polygon, the starting polygon. Okay, so I'm going to set the polygon values somewhere around here, outside the loop or outside the conditions, starting from -1. -1 means no polygon has been created yet. Okay, now if this is the first time creating the polygon, meaning if the polygon number is negative, then you would like to start creating the polygon including this middle point that I've just created. Okay, so polygon is equal to add prim 0 poly and add vertex 0 poly with the middle point that I've created. Okay, and later on I would like to use this primitive that I've created as related to this value, this red one. So at this point I'm also going to apply an attribute to this primitive, set prim attriv 0 val with this corresponding attribute, which in this case a value 2. Right. Okay, now that's when you don't have any polygon being created yet. Okay, so after I have done all these, if I apply, okay, some errors happened. Let me see where that is. Set prim attriv. Okay, I was missing the polygon number. Okay, so currently the polygon only has one vertex, so it doesn't really see anything, cannot really see anything. Then the next thing you want to do is to add this point right here for the polygon. And this last point can be added both when the value is not equal to value, the previous value is not equal to value 2 to the next value, the previous value not equal to the next value, or could also be added right here when the value is equal to, the previous value is equal to the next value. So outside this condition, I can add another vertex. Add vertex to poly. Maybe I need to determine if the polygon is more than 0, meaning if the polygon has been created. Add vertex poly, the pt2, which is this second point, which comes from this one right here. Now if I apply it, did I see anything? So I think I have just I can't really see what's happening here. To debug a little bit easily, I'm going to remove the current geometry, the current primitive, by saying somewhere around here, remove prim 0, remove okay, did it delete it? Huh. I guess it's just created. No, I think it's not being deleted, but I guess I shouldn't do it right here, but I guess I should do it somewhere. Wait, I think it's still okay to do it right here. What if I do it right here? Okay, so this is working. Now, if I do it right here, I'm still seeing all the geometry. And what if I don't add a new polygon? Okay, so it's working. So it seems like this, by using this polygon, I have just wrapped up all the points to create this similar polygon. So what I need to do now is to end creating or end adding the vertex at some point when it reaches to the second middle point number. Okay, that's when you want to stop creating the first polygon and go to the next one to be able to use it as a splitted geometry. So to do that, I need to have another conditions. So that is when the polygon is not equal to 0, not negative, meaning if the polygon has already been created, and if you have found out the next middle point candidate. Okay, and that's when you want to add vertex 0 poly, this new point. Okay, and that's when you also want to stop creating the primitive, I think. So to do that, I'm going to remove and update the polygon number to the new primitive. Add prim 0 poly. Okay, by doing this, now at least I have been able to create the first half squares, and this same process actually works with the diagonal shape like these, so it looks okay. Now what I'm missing is the other half side of the shape. Okay, Okay, close, looks close. So let's also do that. To think of the conditions, after I have created the new polygon at this one, then I have to then keep adding more vertices to create another polygon. So to do that, in this case, what I'm missing is here is the new polygon doesn't really start from the middle point anymore because I haven't done anything to this one. So I'm going to add vertex to the new polygon. I'm going to add this middle point again. Okay. Now start to create this triangle. Now I'm also missing the last one right here. So to have the last point, I actually cannot really look at the last point because the loop only goes 4 times with this conditions right here, because it goes 1, 2, 3, and 4. But what I actually need is another additional 1 loop to go back to the same middle point for the last loop. So what I would just do is to add 1 to this loop, or you could just say I is less or equal to the number of vertices plus offset, and that should fill up the polygon like these. Okay, now if I look back to now, starting to look great, especially when you only have 2 values. It seems to cover up all the conditions pretty clean way. The only things left out is where you have 3 connections or 4 connections, like here at the corner. Okay, so for the new polygon that I've created, let's also set a value, the primitive attribute, just like I did right here. So I'm just gonna copy this one and set this attribute. Okay, now let's think about the other conditions, the polygons at the corner. Now this seems to be a bit tricky, how you want to fill these up. Now I don't really like the colors as well, so let me also fill up the color with the same color from the point. I'm just going to get the color value from each of the point. CD, and where I have created the middle point, it's this one, and using the middle point, which is this one, I am going to set point attrib 0 CD to this MPT, in this case CD2. Right, and same as these, I am going to set the color. Okay, something weird happened right here. Actually, I cannot just copy the valid color as it is, but I think I have to promote it from the primitive attribute instead of trying to set the colors inside a wrangle. So just forget about setting the color at this point. Just gonna go think about how I'm going to fill these holes up. Now for example, for this corner, I probably want to just create a corner like the cross corner like these. So this is pretty straightforward, and all the corners have different values. So the idea here that I could think of how I can fill up is picking all these triangles for each of the corner, for each of the values, and somewhere around here, the middle point of this diagonal edge, I can do the mirroring or the rotate by 180 degrees so that I can fill up the hole for each of the values. And then at the end you'll be able to create this horizontal or the cross-like corner. Now, having the same idea for these corners, I could probably do the same things with these small triangles. I could pick up the middle point and I could rotate 180 degrees to fill up the holes. Now that's where this algorithm in order to create the border might be not so correct. I mean, what I'm trying to do is to try to create this horizontal line connecting like here. But the actual divisions, the actual diagram might not look like that. I'm not sure what's the correct output in terms of this split. It might be that this line itself, this vertical line itself, might shift to the right hand side, or this triangle diagonal line itself is the split line. That might be the answer. I'm not really sure what's the correct answer for this divisions, but what I found natural is to have this horizontal line like these for this kind of a triangle holes. For this one, create a hole, create a horizontal vertical line going from bottom to top, and this one like here. This one might be diagonal line might be better, but changing based on the condition might be difficult. So what I'm gonna do here is to just try to draw the line going to the middle of this triangle to split, so that I can use the same logic for both 4 corners and 3 corners, and that's much easier to deal with. Okay, so keep that in mind. I'm going to check whether now what I need to do now is to see which polygon is triangle and which one is square. In this case, I'm looking at these polygons, and since I am drawing these triangles or squares using this poly equals to add prim, I do need to know which one is the triangle and which one is the squares. Okay, now probably I could do that later, but this one is also triangle, but I only want to check when you have a holes. Okay, so that's the conditions, and that condition happens when you have a unique values more than 3. In this case, you have 3 values neighbored, or 3 values for the points inside this primitive. In this case, you have 4 unique values, so you need to only look onto those conditions. So that is when I probably can do the create the condition somewhere around here if the lengths of n vals, the unique values, is more than 3. Okay, that's the first condition you want to look for, and the other conditions you want to look for is when you are when you have created the triangle shape, meaning the vertex count number is equal to 3 for the primitive, for the current polygon, this one. to achieve how many points you have for the current polygon, you cannot really do like prim points or prim vertices for a dynamically created primitives inside of X. So you need to count it up somewhere inside the loop. So I am going to create some variable to use it to count the vertex number of the primitive. I'm going to name it int vt count starting from 0, and as soon as I have created the polygon, I am going to count this point number by 1. Increment it by 1. So in this case, this is where I have created the initial polygon, adding 1 vertex right here, so the vertex count starts from 1. Okay, and as soon as I have added the vertex using add vertex, I also need to update the vt count by 1, and same at right here. This is the initial vertex for the polygon, so the vt count is going to be resetted to 1 again. Now by let's see this one as well. So in this case, vt count plus plus. So by doing this, you'll be able to track how many points are there for each polygons, and then you can add other conditions. If vt count is equal to 0, equal to 3, meaning you have 3 points, meaning you are looking at the triangle shape, that's where you want to, where you can define that this triangle is the one that you want to flip or rotate. So set prim group 0 triangle prim num, nope, not prim num, but poly with 1. Okay, let's check this out. I am going to use the delete node with triangle group and see if I can retrieve only those triangles that I want to rotate. And there you go. Alright, now I can do the process. I can do the rotation process inside the same wrangle, or maybe out with a different wrangle. Probably I'll just do it inside. Well, maybe not, because I don't really have an information which edge is diagonal or not in this case. So probably after I have set the primitive group, using the different wrangle to do the process might be easier in this case. But for now, getting all those necessary primitive, which one to rotate has been done, so that's great. That's fine. Okay, now so let's do this one. Before going into the actual process, let me do the fuse so that I can merge all the duplicated points. It has been created somewhere around the border. Then try to rotate the shape using another primitive wrangle. Okay. For a triangle. Alright, so let's see what's the easiest way to do. I just need to get this diagonal point position, then based on this positions, I just need to rotate 180 degrees for any of the triangles. So the point position for this one could be the middle point of this bounding box, right? So let's get that. Center is get b box center for each primitive. Wait a minute, this one. Okay, I'm going to use the I2A, get the triangle number, convert it into a string, prim num, use it as a group expression. Okay, and let's see if the center is the one that I am looking for. Int pt add point 0 center. Alright, so right here I have what I want. Okay, that's good. Now I can loop through all the points from the primitive, just get the array of points from the primitive, prim points. Actually, yeah, I guess I still need to do this way. So prim, and loop through all the points. Or you can just do like for each loop together with the transform node. Might be easier for some of you. Get the point position. And then create the rotational matrix. Rotate it by 180 degrees with the y-axis. Then first of all, set the axis for the rotation with the center, then rotate it with the matrix, then make this back to the center of the rotation, and update the point position using center point attrib 0 with set point attrib p at pt with position. Oops. Now, probably I can just do the rotation for the triangle shape, only to the triangle shape. Okay, now some part didn't rotate it. Hasn't been rotated for some reason. Let's see why. Huh. Interesting. Let me change the angle to something small. See what's happening here. Okay. Okay, so it's not using this center point that I was looking for, that I was hoping for. Okay, let me make this back to 0 and try to look for the center back again. Point center pt is equal to add point. Okay, so the center point seems to be correct. Now, I'm probably doing something. Wait a minute. What was the parameter for the rotate? So first comes the matrix, second comes the angle, third comes the axis, so this is correct, I think. What if I rotate 90 degrees? Huh, interesting. Interesting. Okay, I know what's happening right here. Seems like it's trying to for each of the triangles, it is trying to rotate this connected point simultaneously, so that's the reason why it's creating this kind of weird shape. Yeah, seems like this one is fused, so that's the reason. Alright, so instead of rotating the current point, I'm just going to add it as a new point, meaning create it as a new polygon. So int new triangle at prim 0 poly, and I'm going to add it as a new point at point 0 at position and add vertex to this new polygon with this new point. Oops. And I have to rotate 180 degrees. And there you go. And for this new primitive, I need to set a attribute. Set prim attriv with the same value. Okay. Now let me, probably I don't need to fuse it right here, but after creating the mirrored shape, I need to fuse it. And I don't really need to add the center point right here. Okay, now to check if the shape, the division looks all good, let me recolor these based on the value. So I'm going to first delete the point color and change it to a primitive color. I'm going to delete the point color first, then try to show up, visualize the color based on the primitive and see if this works, if this is working. Value. Okay, so here you go. Now, took a lot of time to go through all these steps, but that's how I came up with in order to create this Manhattan diagram for 2D. And it does create a letter clean like division shape like these, so I think could be useful for 2D shape. Now when it comes to 3D, then I guess I should use the other process more, either matching cube or Sdf might be much easier in that case. Alright, so after I've got this process, then the others, the later stuff is going to be much easy to do. I'll just need to, let me just wrap it with the group. First thing what I want to do is to delete all the interior lines. So just gonna do the for loop for each cells, for each primitive, maybe not, for each named primitive, and I'm gonna set the name to val. Okay, so for each iterations I can get a shape like these. Now I can use the divide node to dissolve the shared edges like these. Okay, now it all looks nice now. Now, what do I need to get? What do I need to do now? In order to create it, in order to use it as a Sci-Fi panel, what I'm going to do is, let's see, I'm going to use the bunch off a expand, what was it called? Expand, poly expand 2D. Okay. And change this to offset curve only to the inside. And let's also choose the offset value right here. If I make it too big. Okay, let's make this parameterized. So I'm gonna name it as frame offset 1, or just frame offset from 0 to 1. Make this somewhere around 0.01 or something. Okay. Maybe the initial value could be 0.01 and see what happens. So I have a little bit of space, a little bit of margins right here. Controlled margins. It already looks nice, right? Now I'm gonna do the additional poly expand node, which I'm going to use it as a frame, not this one. Poly expand 2D. Now for these one, I'm going to paste the parameter that I have brought up. And let's make this like 0.2, only to the inside. Okay, for offset surface probably for this one, so that I can get this band. Alright, looks nice. Now let me also get the inner shape as well to fill it up. So let's do that. Just going to copy this one and just change it to the offset curve. We'll be able to create the inner shape. And I'm gonna group them differently. One is called as interior. One is actually, this is a frame, so frame, frame, and this one is interior. Okay, now let's merge these together. I'll be able to create this kind of shape. Now this itself is fine, but I would like to do additional things. I'm going to try to create additional like frame using the same function right here. Same Manhattan distance diagram, but using a different point positions. It's using the same using the different global seed. And for these shapes, I would like to use it as a pipe-like geometry. Like I would like to create a pipe-like shape with these. And I'm going to reduce the number of points with this one. Let's say half size. And see. Let's go with these. Looks nice. Now let me go back to the frame and try to make it a bit three-dimensional by extruding both faces with different thickness. Okay, so starting with the frame, poly extrude for the frame, I'm going to extrude it by I don't know, 0.4 or something. Maybe I can parameterize this as well. So all the rest of the stuff that I'm doing here is not really algorithmic. It's just more of a procedural, normal procedure modeling. So it's pretty easy to do. Frame height. Just this Manhattan diagram. I spend a lot of time doing the coding, but rest of the stuff, not much. Okay. Interior height. Okay, so let's set the frame height to 0.5, interior height to 0.2. Copy these for this frame. And maybe I'll put the back side as well. And this one is for the interior. And using the different values. Interior height. Okay, now inside this frame I would like to create kind of a pipe-like shape which its attributes being animated, like it's something, some informations or some liquid is running through those pipes. And that's the end of what I would like to do. And for those pipe shape I'm going to use the other Manhattan diagram. The process is pretty much the same. I am going to first of all loop through all these cells using the same things that I did here for each named primitive for the val. Okay, and I'm going to use the divide node to dissolve the unshared or the shared edges. Now for each of the cells, we'd like to create a offsetted curve, offsetted like outline, and use it as a pipe network. Okay, so to do that, I'm going for each of the cells inside the loop, which I'm not seeing right now. Okay, so for example this one, let's say I would like to have 5 offset, 5 pipes created from this shape. I'm just going to have another loop inside right here 5 times. I don't need these connection. Not this one. Let's set this to, maybe I can just change the number of loops for the pipe, or maybe I could make it randomized as well. Pipes, number of pipes from 0 to 10 is fine. Let's set it to 5 for now. Copy this. Paste it right here. Now for each loop I'm going to use the poly expand again, and I would like to decide the thickness. Now it might be interesting to make the offset different for each cells. Maybe each cell has different offset values. Might be interesting. So let's create that value as a detail attribute before this. Inside this loop, I'm going to create a meta node so that I can use the detail attribute like iteration or value as a random seed. for each cells. So I'm going to create an attribute wrangle, connect it like this, and I'm going to change this to detail attribute or detail wrangle, then get the value from the detail from the second input, in this case iteration, and then let's try to change the thickness. What kind of value? What will be the name for this one? I'll just say, since later on I'm gonna change this to a pipe thickness and probably use it as a p-scale, gonna name it as a p-scale. Maybe it's a bit, because the p-scale is a globally taken stuff. I'm just gonna name it a thickness. Okay, and thickness is equal to random value. So let's set the minimum and the maximum for the thickness. So first of all, I'm going to create the random values based on the iteration multiplied by some custom values plus some seed parameter. Then use the fit 0, 1 to remap between the minimum thickness to the maximum thickness. Alright, so the seed can be anything. Probably I could bring this right here. Let me uncheck this one and drag and drop those parameters. Okay, the min thickness, minimum pipe thickness. This one is maximum pipe thickness, maximum pipe thickness, and probably 0 to 1 is fine as a range. Okay, now let's make it from 0.05 to just 1 or something. Or 0.2. Not sure what's the right range. Okay, now if I look at the detail, I should be able to get this thickness. Now let's try to access this one inside this loop. I'm going back to this poly expand 2D, looking at this offset right here. I'm going to get the detail attribute detail, get the OP input, get the self attribute named as thickness. Okay, it's 0.0001. If that's, I'm not sure if this is correct. Huh. Looks too thin, isn't it? 0.0001. I'm not sure if this is correct. Let me see. Okay, spell mistake. Spell mistake. Has to be thickness. Alright, now going back to the poly expand. I don't want to expand to the outside, but only to the inside. And probably using as a curve, it's fine. I'm also going to get it as an outline, so I'm going to use the primitive node to like these. Now, seems like I'm only seeing one shape, and that is because I think I need to change this thickness based on this second for loop iteration, starting from 0, I guess. Right, so let's do that. I'm going to multiply it by detail for each count 1, iteration 0. Right, as an output, what do I get? Okay, looks nice. And this is the result that I get. This already looks like some kind of sci-fi like pattern. Yeah, looks nice, I think. Now let's see if I change the seed. It changes the thickness. You can also control the minimum thickness for the random and the maximum thickness. Alright, looks good. Alright. So out of these, I would like to set the pipe geometry. So probably might be a good idea to set this p scale value or any attribute value to each of the point so that I can later on use it together with the node-like pipe, poly tube, poly wire. Forgot what was the name. So let's do that right here. I'm gonna use the point wrangle. I'm gonna name this p scale. And what was the f at p scale is equal to detail 0 thickness. Now since the p scale is going to be used as the radius, I should just set the half size of the thickness from the detail. Alright, let's see. Point. Do I have this p scale? Yep. Okay, looks good. Now going outside the loop, I am now going to now I'm going to try to create this pipe poly wire. Let me make the divisions to something smoother, and then change the radius to p scale. Okay, looks nice. Now there are no margins if you just use the p scale as it is. So if you need a little bit of margins, probably you could do the subtraction or multiplication with some 0.99 or something, 0.9, so that you get a little bit of space in between the pipe. Okay, this looks nice. Now, as an additional thing that I would like to do, since these pipe, I'm gonna try to merge these together with this frame. No, I'm not seeing the pipe. Let me try to bring this up a little bit based on these thickness value, frame height, and the interior height. I'm gonna copy the frame height, paste it to the y direction, and also I'm gonna copy this interior height, copy, and do the subtraction with these. And calculate the half size plus interior height. so that the pipe shape will go in between the interior and the frame, like these. Now starting to look like a shape that I wanted. Okay, almost there. Let's try to create some animations for those pipes, which run through those pipes with some colors. And later on, maybe you can bring it to like renderings or to a game engines like I did to animate it. Okay, so one of the things that I would like to try out is to use the ID from each of the cell. Probably I could go back to this one, right? Maybe still this one is fine. I'm just going to get the interior shape by getting the interior group. And each of the primitive has its own values. If you look at the primitive attribute, there's a value. Okay, everything is 0. Seems like not. Okay. Seems like the value is missing here. Let me try to visualize this based on the point number, point attribute, and see if I'm getting what I want. Ramp from attribute, val, or random from attribute. Okay, not really what I want. And for the primitive, nope. So the value, the index value is missing right here. So maybe it has been gone somewhere throughout this process. So let's see. Where did it? Delete it. So at this time you still have it right here. You still have it. Nope. At this point, some of the primitive has the value equal to 0. This one as well. Huh. Interesting. Okay, I see what I... no, these are the points, but what I need to look at is these primitive. Okay, so primitive looks fine. Primitive still have... It's okay, so at this point the value has gone after the poly expand. So I'll just do the transfer, attribute transfer. I'm not sure if the attribute transfer can be used for primitive. Probably you could. What I want to transfer is the primitive attribute called val. And okay, now here you go. Okay, now looks good. Now with these values, what I want to do is to transfer these values into this pipe, and based on the position of the pipe, I would like to change its color based on these covering values, covering colors or values. So maybe before getting into the polywire, I can do it for those curves. Use the point wrangle for each of the curve points. I can refer to these primitive with this value attribute and check the closest value. In this case, what was the name called? XYZ distance, was it? To get the closest primitive and its number, I think. Was it? XYZ dist. So So from to the second input from the right, and the prim number and UV. I don't really need a UV. Int prim and vector UV as an output parameter, and you'll be able to get the closest distance using the XYZ distance. Now what I need is this primitive number right here. Now from this primitive number I'll be able to get the value, so now I can transfer this value into each of the point on this, how do I say, this pipe curve. Okay, now let's check this out. If I look at the point attribute, I should have this value being transferred. Okay, everything is 0. Why is that? Okay, it's not really working. So I did this XYZ distance from the current point. I have to get from the second input. Alright, check this out. Okay, now I seem to have this corresponding values. Let's check this out. Just going to try to color these point based on the closest frame value, random from attribute, or random from attribute using val. Alright, looks good. And if I do it like these, so and by doing this, it looks like the pipe has been like segmented using the frame above it. Even though it is a totally separate geometry, it looks like these pipes are related to this frame. Okay, that looks good. Now, probably I'm just gonna use this color as it is, and the other things that I would like to do is to add additional animated values to each of the pipe shape to make it look like something is running through the pipe. Maybe some white color is running clockwise or counterclockwise randomly in a loop. So let's try to create that, and I will end this tutorial. Okay, where should I do that? After I have transferred this value and change the color, maybe somewhere after changing the color might do the job. So point wrangle, create the animate pipe as a point wrangle. Okay, and then what was I trying to do? Okay, so first of all, I'm going to get the color value, and then let's say the tail color is black and the head color is white and the in middle color is this color. So I'm going to create two I want to create a gradational color value. Well, I'm just gonna create head and tail color. So tail is equal to set 0, 0, 0. Vector head is equal to 0, set 1, 1, 1. That's white. And now I am going to loop through all these three colors based on the positions. Now to get the positions out of the curve, I think it's a good idea to get the curve u value, I mean the UV's u value for the curve. The easiest way I could do is to redo the resample, but I think if I just do the resample, then it might just do something wrong with this pipe. Even though if I click this one, I do have a little bit of split right here, and doesn't seem to do a better job. Even if I do the fuse, seems to do some ugly results like right here. So I don't want to use this fuse nor resample, but instead let's try to estimate this curve u value that you can get out of resample node, which is in between 0 to 1 based on the positions of the point on top of the curve. Now to do that, let me go to a Vex function page to see what kind of functions I could use. I remember I used something to calculate the distance from one point to another. Houdini Vex functions. What was it called? Distance. Okay. Finds the distance of UV coordinated geometry in UV space. Maybe not. Surface distance. Finds the distance of a point to a geometry point along the surface of a geometry. Now this might be able... This could be useful. I am not sure if this can be used for a polyline though. Other one. Not much. Okay, let's try to see if I can use this surface distance for a polyline. It says surface, so might not be able to use it. Let me just check. Okay. So let me bring this up. The parameter seems a lot. Alright. Okay, so I do have the current point position, which is also the point number as well, and in order to get the end point, end point can be like the first point as well, so maybe 0 might be the one. But wait, I want to know if this point has been fused or not. Maybe it is. Let me just pick one off the primitive. Okay, and let's see if this can be fused to remove or merge to change the point number. So previously it was 100 points, and this is after fuse it's still 100 points, so this already has been fused. So probably the surface distance cannot be used after all. Alright. So what's the other method? Surface. Yeah, I guess this doesn't really work. Because I think it just searches for the closest distance. Now, what's this one? Returns the distance to the closest UV coordinate of the geometry in UV space. This will find positions on the surface of the geometry, not just point positions. Max distance, the primitive UV coordinates closest primitive. The primitive UV function can be used to evaluate maximum distance to search in UV space. The operation can be sped up if it allows it to quit early. Alright. I don't know. Might be not the solution. So instead of doing all those stuff, I'm gonna do a bit more brute force way. For points, I'm going to create the loop through. Wait a minute. First of all, I do need to make sure that the point is in the order, the clockwise order or counterclockwise order. So if not, I have to use the vertex numbers instead. So let me make sure of that first. Okay, checking the point numbers. So starting from 0, going clockwise. Okay, looks like it is going clockwise till the end. So that looks good. Alright, now I'm not sure if there's an easy way to estimate the same thing you do in resample node, like curve view. If anybody know if anybody want any tips, let me know. What I could think of right now is using the for loop until the current point number from that 0, then just calculate all the distance. And wait a minute, actually I have to first get the primitive number out of this point, point prims. So probably I should do primitive wrangle instead. Int pts is equal to prim points, and then use the for loop. Now let's create the length variable starting from 0, and then at each point I'm going to calculate the length between the point at the I index and the point at the I plus 1 index, and add it to this length at each iterations, and as a result you'll be able to get for each of the points you'll be able to get the length from the first point, always from the first point. Then later on you can just divide it by the total length of the curve, then it will be remapping between 0 to 1. Yeah, should work. So PTS minus 1, I should get 2 points. One is PTS 0, nope, PTS I, and PT2 PTS I plus 1 modulus length PTS. Okay, vector position 1 is equal to point PT1 point PT2. Now I can calculate the distance between those 2 points. Position 1, position 2, then add it to the length. Alright, then this updated length is going to be added to the attribute of this point, probably to the point 2, so set point attrib 0, or yeah, I'll just do it. So what's the value? Actually, I shouldn't add it as an attribute right now, but yeah, I could do that. But probably it's a good idea to get the full length of the curve previously. So I'll use the measure node to calculate the parameter of the primitive, so that at this point I can remap the lengths between 0 to 1. So set point attrib 0. I'll just name the curve u at pt2 with a length divided by the perimeter of the curve. What's the spell? Perimeter. Okay. That should work. And I am missing the first point to be added to this as an attribute. So for the first point, set point attrib 0, pts 0 with 0, because the length starts from 0. Or I can just say length. Set curve u. Okay. Let's see. If I look at it, and the curve u is in between 0 to 1, and let's try to visualize this one to see if I'm getting the right values. So I'm going to test it out using the color node, change this to ramp from attribute, and use the curve u. Now if it's going from white to black or black to white as a gradation, it means it's okay. I have done it correctly. I think it's going okay. I think so. Yeah. Now that I have this values, it's time to make a animation. Right. Now I can do it. Probably I'll just name this curve u, and I'm gonna create another point wrangle because accessing to each of the points simultaneously is much faster. So rather than using primitive wrangles, I'm gonna use the separate wrangle, animate color, and try to create the animated value using those curve u and these original color that I have right now. So I can cut this out, which I'm not using, paste it into the point wrangle, and let's also get the curve u. Okay. First thing first, I'm going to create a random value for each of the primitive. So based on the primitive value, I would like to get the primitive number out of this point using point prims 0 at ptnum, and get the first one. And this is going to be used as a seed. The float random offset is going to be rand prim multiplied by some custom values plus some seed value. Okay, now this is an offset which is going to be used to change the starting point for the animation. So it is going to be added to the curve u, to current curve u, plus a rand offset. Okay, and you always want to make the range of this value in between 0 to 1 for ease of usage. So I'm going to calculate the remains like this. Okay. Now, what else? And after this, I can try to, since I would like to use this frame value as well for the animation, let's reduce the frame number to 60 to make it as range for one loop. Let's bring this up somewhere. Float f is equal to at frame. Oops. Okay. I think it freezed. Frame divided by f end. Let's make sure this is a float value. So the value will be in between 0 to 1. Now, I would like to add that to right here as well. Okay. Now, the curve U is going to be updated like this. And now, based on this value, I would like to change or set the color using those head, tail, and the original color. Okay, so how do I do that? The original color. First of all, I'm going to do the gradation between the head or a tail to this middle color. So you can do that by lerp tail call with curve U. See how this works. Did it change anything? Doesn't seem like so. Okay. Am I missing something? Okay, let me make sure that I am getting the curve U as I want it. Curve U. So curve U is like this, and if I do okay, so it is changing. The color is also changing, but somehow the color shown right here is not changing. What if I do it like this? Okay, so I do see some color changes in this case, in this way. So I'm not sure if this is correct. Let me also create the head color as well. So we add CD. I'm going to update it. Lerp. Now from the current CD to the head using another curve U. Okay, probably I do need to change the lerp value a little bit. Okay, so let me change this to let me maximize the color value 2.5. This one to minimize. Wait a minute. Wait, the other way around, I think. Max 0.5, minimum 0.5. Oops, it's all gone. Is it as a way around? Okay, a little bit better. Okay, am I seeing the pattern now? If I combine it together with the frames. Okay, I think I might want to have a little bit of more whitey area and more black-like area. So let's try to go back and change the color blur function to a little bit more. So first I am going to lerp it between tail to head. Okay, lerp tail to head with the original curve view value. And let's see how this works. This should create a black and white gradient animation, and probably I would like to make this go the other way around, so from head to tail. Okay, looks nice now. Now somewhere in between the black and white, I would like to merge these color value so that I can indicate the different panels, like those pipes are belonging to different panels. Okay, so one of the way I could think of, I don't know, multiply it by color, and probably I could make the head value by 2 to make it more wider, or maybe makes it more brighter. Guess it's fine like these. Or probably you could also try to create like power functions. Well, I'll just go with these. Looks okay. Now, after all these, I'm going to also color these frames as well with different values and wrap this up. Right. If you are still here listening and interested in trying to see how I would do in SDF, I could also try that as well. Let me know if anybody's interested. Okay, so which one I should do for the... Currently this is the point color, so this has to be a point color as well, but this one doesn't have a point information which groups exist, which groups belongs to which one, so I'll just color it right here. Okay, so for the frame, let's make it dark color. The interior shape, I want to make it a little bit grayish. Alright, and this is what I got as a result. Let's try to wrap up all the parameters. Forgot to set a seed. Copy this parameter and seed it to this point seed here. And to this one as well with the different value. Adding some additional numbers. Alright. Okay, so everything is set. I can now create a different kind of shape, panel like shape. Like these. And if you render it, it will look like what I have shown here. And this is the one that I have imported inside Unreal Engine 5. What's this cube? I think it's an actor or something. So it looks like these by doing the rendering. Yep. And I am using, in this Unreal Engine, I'm using the same method that I have explained in the last video, showing you how you can send a geometry with a attribute, the custom attributes. In this case, there's just one like animated color attribute, so it's not that hard to do. You probably might not need to do that texture way, a VAT way, but just have this color, animated colors being saved and send it to a UE file. But somehow this animated color didn't really work inside UE file by importing it in Alembic, so I was still using the vertex texture. Okay, so chips, you are interested in SDF, so yeah, let me try how I can do this using SDF. Now you might not be able to get the crisp edges using SDF, but let's see. So I'm gonna try with some sphere, see how I can split this sphere with this Manhattan distance. Okay. Alright, I am going to make this as a polygon. Gonna make sure I have smooth surface. Now let's convert this into a SDF by first of all, I'm going to convert it into a volume, so ISO offset, because working with the volume is easier in this case, because I want to also use the interior volume values. So let's make the resolutions high enough. 50 might be good enough to test out. Now let's scatter some points, which is going to be used as the center of the cell. Too many numbers. Let's say, let's stop by 10 points, right? Okay, now I'm gonna use the volume wrangle for the volume with these points, and pretty much the same things that I'm gonna do with the one that I have done right here, trying to get the Manhattan distance. I'm gonna copy this distance equations, go back to here, and I am going to check all the points from the second input, and points 0, 1, and get the min distance. And right, so calculate the distance. To do that, I am going to get the position from the second input. Now in this case you do need the y value as well, so I'm going to add that as well. Position y minus py. Alright, and check if the minimum distance is smaller than or larger than distance, and if so, update minimum distance with this one, and also try to get the current index, the minimum index. Alright. Okay, now that I have those information, what I'm going to do is to first let's name this volume density. And probably might be a good idea to have additional volumes as additional informations. Do I need it? Maybe just one is fine. I'm not sure. Density. Okay, so I am going to update this density value with this index that I have found. Okay. Now, okay, spell mistake. Density. Am I getting the right value? Not sure. To check out if I'm getting the right value as an index, I can temporarily add the point where the current density is larger than 0. And let me go this way. And then set some attribute to this point with the current density. Okay, seems like nothing has been added, does it? I guess I need to access to a density value. Wait a minute. Density. Okay, I'm getting the fog. Using the volume wrangle. Previously, I was able to add a point like this to debug. I'm not sure if it has been disabled or not. It is at the center. Ah, wait a minute. Huh. I think I need to set it as point positions. At P. Alright. Now, let me remove this one. Okay, and what I would like to check is if density is being set. Okay, everything is -1, so it is obviously wrong. Now what did I do wrong? The minimum distance has to start from big numbers. That's the problem. That was the problem. Okay, so now I can see the index value has been applied to the point from 0 to 9. Alright, looks good. Now that's for the debugging, and I can left out with this density value. Okay, now that I have this information, and probably I just want to make it where you have the original sphere shape. So if f at density is equal more than 0, then you want to update. And probably you don't want to use 0 as an index, because 0 has been used for the empty space. So I'm going to add it by 1 so that the minimum will be equal to 1. Else, just set the density to 0. Okay, now that I have this information, I can create another volume wrangle. This one is just to check the, or calculate the Manhattan distance. The next step you want to do is to use this density, or use this index value which has been applied to this density, and use it to determine which area is the one you want to make it as a border surface. Okay, now to do that, let's see what's the best way to do that. Volume wrangle. I could think trying to use some volume surface related value related function like something like volume, or you can just use convert node. There's also a volume surface. Wait, I'm not sure which one's good, better for the... Let me try with this convert. And this one has the volume offset right here, which you can use to see, say which value should be used to split as intersections. Now this itself already creates some nice split right here. Now what I want to do this is to do this same things for all the possible indexes, right? So let's see. In this case, I have from 1 to 10, right? What happens if I do to 10? Nothing. 9. Okay. 8. So it's being added one by one. Okay, so maybe what I could do is to use something like for loop to access each of the index. Then for each of the index, I could use this convert to convert the volume into this kind of shape, one by one, separately. Okay, shall we do that? Alright, so let's try to do that. I know a number, I know how many numbers of cells I have because it is being set with this point. Currently it's 10. So I could say for each number and copy this point and paste it right here, right? And then for each loop, I would like to pick a corresponding indexes. So I'm going to use the volume wrangle and get the iteration value. Int iterations equal to detail iteration. Now since the value starts from the index value starts from 1 because I have added by 1, so I'm going to add 1 to this one, and I'm gonna check if the current density is equal to, maybe I should do the calculation like this: if a subtraction between the density and the iteration and the result is small enough, close to 0, I'm gonna make it as an absolute value smaller than 0.001, which means it's really close to 0, then that's the one you want to pick at this iteration. Now in that case, I'm going to set the density to 1, else 0. And you are left out with this part. Okay, now you can just use the convert node to convert it into a shape using threshold like 0.5 or something. Let's see what's the best value. 0.5 probably. Okay, and let's see what would happen. And this is what it looks like. It doesn't really look clean at all. But so if you want to make it more smoother, what's the best way? Let me think. Before getting into this volume wrangle, I could try using like a blur, volume blur. Ooh, doesn't do much good job. Yeah, it's not a good idea. Now to make it smoother, what I need is the neighbor values to be really smooth, but in this case it's a bit hard to retrieve that information. It's a bit hard to do. Well, let me just pack this up and see how each of the cell look like. I'm going to use the point wrangle to separate those parts a bit. Okay, but inside looks good enough, probably. And if I increase the resolutions for the volume, it should increase the resolutions, the overall resolutions as well, I think. Let's try that out. If I make this to 200, let me save this first. And wait for it. See how it looks like. Okay, it's taking a little bit of time. Alright, now it looks much crisp at this point. Now this is actually not an SDF, this was a volume way, but pretty much the same thing. So this is kind of a three-dimensional result of a Manhattan diagram. Looks interesting. Alright, so hope you find this interesting. I'm not sure if that can be directly used for anything. But I do like the result. I'm gonna make this back to 50 and leave it as it is. Alright, so let me know if you have any questions so far. If not, I'm gonna left this out right here, which is not really related to what I did right here for the final result, but just for the reference. And I am going to upload the file as I do all the time, so you can download the file from the video description page and you can refer to it, how I did it. So if no questions anymore, I would like to end the tutorial today. And so thank you for watching, and thank you for all the comments. And sorry that for some of the node I couldn't really use it because I haven't really used it myself. Tried it myself previously, so probably I do need to check it out myself, especially like the one from the labs. I don't still know what each of these do yet. But thanks for all the suggestions, and I learned a lot. Okay, so thank you. And I am doing this tutorial weekly every Wednesday at 10 p.m. Japan time, so if you are interested in this kind of algorithmic design stuff, and then you are more than welcome to join at any time. Okay, so see you next time. I'm also doing a Patreon page myself, so if you're interested in supporting me, that would also be great. Okay, so good night, and see you next time. I will upload the file after I have stopped the live. Okay. Okay, good night.